Okay. Oops, sorry. So balancing equations. How many of you guys love puzzles? Anyone love puzzles? No. How many of you can do like a 6-piece puzzle though? Like I could give you like a 6-piece puzzle. Okay. Same idea, same concept. This is just a puzzle. It's like a 6-piece puzzle. Okay, so I'm going to teach you how I do it, and I do it in steps every single time. If you do it in steps, I promise you, I have taught this for 7 years now. If you do it in the steps, you will be more successful. I'm not saying you can't be successful without the steps. I'm saying you will probably be more successful. Okay, so the very first thing you're going to do is you're going to draw a line down the center. Of the arrow. So the first thing you'll do is you'll draw a line down the center of the arrow. Okay, why? Because it follows conservation of mass. So anything we had before the reaction, we will have after the reaction. So I'm basically showing you that they're going to be equal. Okay, they're going to be equal. Kind of like when we did the nuclear equations, that the tops are equal, bottoms are equal. These things are going to have equal amounts of atoms. So the second thing you are going to do is you are going to list the elements. Remember, the elements have capital letters. So every time you have a capital letter, that's a new element. So these two, we have Na and we have Cl. I just list them in the center. If you want to write them slightly off to the edge so there's not a line down them, that's fine too. But we're going to list the elements. Na and Cl is what's dealing with in this one. The third step is you're going to count the atoms on each, count the atoms of each element on each side. Count the atoms of each element on each side. So this is the reason why I taught you to count atoms first, is so that you could do this step. So remember, if there's nothing out in front of them, it's 1. So you have 1 times by 1, you have 1 Na. 1 times by 2, you have 2 Cls. 1 times by 1, you have 1 Na. 1 times by 1, you have 1 Cl. So each side I count separately. I count the NAs on the left, I count the NAs on the right. Count the Cls on the left, count the Cls on the right. Now balancing is exactly what it says it is. We're going to try and make them equal. Like balancing a teeter-totter, you're going to make it equal. So the fourth step is you change the coefficient, not the small number, not the subscript. Change the coefficient, so the number out front, till each side has equal amounts of each element. So I will change the coefficient until each side has equal amounts of each element. Now this won't always be pretty. Sometimes you will change a lot of numbers. Sometimes you will mark numbers out multiple times. Sometimes it will feel like relentless, like I just changed this one, I just changed this one. It's going to be sometimes difficult. Sometimes it won't be. So on this one, you'll see our NAs, they're good. There's 1 and 1 on both sides. But our CLs, there's 2 on the left. So what number could I make this coefficient to make it where I have 2 CLs on the right? I could make it 2. Now here's where people start to mess up. I have to give this 2 now to everyone over here. So that 2 has to get times by 1, the subscript for Na. So now I have 2 NAs. That 2 now has to be times by the 1 for this subscript. I now have 2 CLs. You're going to be like, but you messed up the NAs. It just makes it where there's another step. So some people struggle with this because they're like, I don't want to mess something up. Like NAs were already good. But you have to keep with the steps. So now I have to fix the 2 over here. So NA, I need 2 NAs on the left. So now if I put a 2 for the coefficient, I now have 2 times by 1. I now have 2 NAs. Again, the biggest problem I have with this is people forgetting if there is a compound here, you have to distribute the 2. The kicker here, the really important thing is, we did not distribute this 2 to the CL because there is a plus sign. See this as a stop sign for distributing. Do not give the coefficient to anyone on the other side of the plus sign, okay? So make sure you give it to everyone in a compound, but make sure you stop at the plus. It's the biggest problems with balancing. Okay, so we're going to do harder problems. Okay, so this would be like your basic. Like you understand some very minimum basics. So now I'm going to give you a harder one. So right off the bat, what do you notice as making this one harder? Right off the bat, what do you notice makes this one harder? 2? 2 what? There's 2 different compounds with O's in it. That's going to make it a little bit more difficult. Okay? So we're going to work through it. We're going to follow the same rules though. Draw a line down the center. List out my elements. I have Na and I have O. You might go, Miss Ryan, you have 2 O's over here. They're still O though. They're still oxygen. The only type of atoms I have is Na and O. Now I'm going to follow my next step. Count the atoms of each element on each side. And here's where it gets a little tricky, guys. Okay, here's where it gets a little tricky. So the left side's fine. It's the same way for counting. So we have 1 times by 2. We have 2 NAs. 1 times by 2. We have 2 O's. Even the NA is on the right side. Not too bad. 1 times by 2. We have 2 NAs. The O's are the problem. The O's are the problem. You have 2 compounds with O's. That means together, how many O's do they have? So the left compound has 1 times by 1, so it has 1, plus, it's the only time you're adding in this whole thing is right now, the only time you're adding, so don't multiply, because you have an O with this sodium, but now you have another compound with 2 more O's, so you add them together to get a total of 3. So that's one of the hardest parts to these types of equations is now going to be keeping it straight. So I can work you through this 2 different ways. I'm going to work you through it the just more mathematical way, and then I'll work you through it the conceptual way. Okay. So first of all, we'll notice that we have 2 sodiums on both the left and the right, but the oxygens don't match. You have 3 over here. You have 2 over here. So we need more oxygens over here. Nothing you can multiply by 2 is going to get you to 3. You can't have a half. You can't have 1.5. It has to be a whole number. So we're just going to put one down. Okay, we're just going to pick one and go with it. So I'm just going to go up by 2. Okay, I'm just going to go up by 2. And we're going to keep working through it. So 2 times by 2 is going to give me 4 NAs. 2 times by 2 is going to give me 4 O's. Okay, now I'm going to move to the other side. Okay, you have 2 choices. You can go back and fix NAs first or O's. I'm going to just fix NAs, which will actually solve my O problem as well. But I need 4 NAs over here. So I'm now going to put a 2 here, because 2 times by 2 will now give me 4 NAs. And then 2 times by 1 will give me 2 O's on this one, plus I have 2 more O's. So I now have a total of 4 O's, and it's balanced. And here's going to be a really important point. So that's how you might mathematically work through it. If you have an odd number of oxygen on the one side and even on the other, make the odd side even. So this tip will, some of you guys will understand it, and some of you guys, it may not click. Might not click for a few days. It may never click, and that's okay. But basically, we had an odd amount of oxygens on the right side. We had 3. It's an odd number. You can never make an even number odd. So meaning, there is nothing I can multiply by this to get to an odd number that's a whole number to be multiplied by. I can't. I can never do something that a whole number times 2 will never be odd. Just won't. So the first step could have just been is making this O over here even. Again, if it doesn't, just let it keep going. But if that does click, it will save you some time. So sometimes you just make the odds even. Okay. We are going to do another one, and then we'll be done, guys. Let's do one more. Let's do one that's a little bit more beefy, and then we'll be done. Okay, so hopefully I don't run out of room. Ha! That's for you guys. Okay, so this is a very beefy one. It's very beefy. There's a lot of letters, there's a lot of numbers. So it's Ga, which is gallium, and then we have fluorine, 3, plus sodium with phosphorus, and then oxygen, 4, reacts to produce gallium PO4 plus sodium chlorine. Just because you have a lot of letters, though, doesn't mean that it's a hard problem. Okay? Just because you have a lot of letters does not mean it's a hard problem. Sometimes there's just a lot of letters. So we're going to follow the same exact steps. So I'm going to draw a line down the center. I'm not going to get overwhelmed, but there's a lot of stuff. I draw a line down the center. I'm going to list my elements, which are Ga, F, Na, P, and O. And then I'm going to count them. Okay? I'm going to count them. So GA, 1 times by 1, I have 1 GA. 1 times by 3, I have 3 Fs. 1 times by 1, I have 1 NA. 1 times by 1, I have 1 P. And then 1 times by 4, I have 4 O's. I just pick the order of the elements based on which order they come in. Like, I just read left to right as I write them. I don't have some weird, like, always put H at the top. Like, there's no rule for that for me. It's just list them how you see it. Now I'm going to count my right side. 1 times by 1, I have 1 GA. 1 times by 1, I have 1 P. 1 times by 4, I have 4 O's. 1 times by 1, I have 1 NA. And 1 times by 1, I have 1 F. Okay, so from here, oh, sorry guys, I've missed out on a number. I apologize. There's a 3 here. I apologize. That's a 3. I just copied down the problem wrong. Okay, so this actually has a really easy fix. So galliums, good. Fluorines, no bueno. So left side has 3. I need 3 on the right. So in order to get 3 Fs, 1 times by 3 is going to get me to 3 Fs. But now I got to take that 3 and I got to distribute it both to the Na and the F. So now 3 times by 1, I now have 3 NAs. 3 times by 1, I now have 3 Fs. And like I said, just because it's a big amount of atoms, it wasn't very hard at all. Okay. One more small bit. I'm not giving you another example. I'm just giving you a hint. You always have to write in the reduced form. And that might not make much sense to you, but what I mean by that is you can't, or you shouldn't be writing 4Na plus 2Cl2 goes to 4NaCl. Oh, sorry. So this is not okay. Why it's not okay is because you can reduce these numbers. You have too much, in other words. It's not wrong, it's balanced, but you have too much. So you can divide both these, or all 3 of these numbers by 2 and still have a whole number. So the correct answer here should be this. This is correct. And again, it probably won't make sense to you until you get to a problem that you keep getting wrong and you're like, why is this wrong? It is because it needs to be reduced. It needs to be in its smaller form. Okay. I